Social technical systems exhibit unprecedented complexity. Any imbalance can cause blackouts and traffic jams with catastrophic impact. How can we combat these tragedies of the commons in the digital era? A sustainable development pathway for our digital society requires new means to self-regulate the consumption and production of physical resources, such as energy. In particular, power grids experience significant risks and uncertainties. The penetration of electric vehicles and distributed energy resources, highly volatile production from renewables, and an unpredictable demand during times such as pandemic lockdowns. All these challenge such systems to adapt and prevent catastrophic blackouts. The digital transformation promises new means to combat such uncertainties. Smart interactive sensors in our homes, in our vehicles, and in our phones provide revolutionary opportunities to collect fine-grained data based on which system operators and power utilities can predict instabilities and promptly respond. Sensor data, though, can often reveal sensitive personal information, from occupancy and lifestyle to mobility patterns and even what TV programs we watch.
Such personal data are often the basis for algorithmic discrimination and manipulative nudging, putting at risk our autonomy and democratic values on how we make decisions. We envision a radically alternative, human-centered approach based on the concept of collective learning.
The EPOS project has applied collective learning to power grids to prevent blackouts, transport systems to minimize traffic congestion, and load balancing of bike-sharing infrastructure and stations.
So this is the open source code for collective learning. It's accessible for the broader community. And here you can see how the system works. The agents, the appliances, they interact in a distributed way to learn the schedules that optimize the power grid, the schedules that can prevent a power blackout. It looks like this network here. So we have the nodes which resemble the appliances at home. And the purpose of this network is to coordinate the choices for the power demand. This coordination happens in a bottom-up way, starting from the leaves up to the root, and then the root initiates a backpropagation process that reaches again back to the leaves. The process repeats and the power demand is regulated and blackouts are prevented. Via collective learning, several highly complex computational problems, combinatorial in nature, can be solved efficiently while aligning with citizens' social values.
By crowdsourcing several management and regulatory operations back to consumers and producers, system operators and utilities can significantly reduce their costs. Collective learning promises a new decarbonisation and sustainability pathway with active citizens' engagement.